It may look like a model airplane, but this plane is anything but a toy. It's called the Tempest, a highly sophisticated unmanned aircraft designed to fly at up to 80 miles per hour underneath supercell thunderstorms, while at the same time gathering data to help meteorologists better understand the dynamics of these storms, the type of storms that can spawn the most dangerous tornadoes.
We have multiple goals or objectives. The first is to demonstrate the feasibility of using a small, inexpensive unmanned aircraft to fly beneath various parts of the developing storm.
Brian Argrove is director of the CU Boulder Research and Engineering Center for Unmanned Vehicles. Argrove, Assistant Professor Eric Frew, and their team of graduate students built the Tempest based on a competition glider designed by Skip Miller, a Boulder-based builder of high-performance model aircraft.
These high-performance gliders have set high-speed records and in terms of how fast they fly, and they're designed to withstand high G loading. So those are some of the characteristics that we think will ensure that we are able to successfully fly through these various regions of the thunderstorm.
Though the Tempest is not large, its wingspan is 10.5 feet and it weighs only 12 pounds, it is loaded with big-time weather instruments.
The Tempest is primarily going to be carrying a pressure, temperature, and humidity sensor. These are very small instruments, and they have the sensors on the outside of it. We have this sensor enclosed in a tube that we have installed on the outside of the wing. We have it in a structure that protects it, but also allows airflow so that we can get accurate atmospheric readings. It's aerodynamically shaped so that it doesn't affect the performance of the aircraft at all. That instrument ties into our avionics pack in the plane itself. The avionics pack consists of this unit, which has the autopilot. It also has networking equipment on board, which basically is a small computer.
The aircraft is all electric powered. Electric motor right up front, a folding propeller. So when the motor is not running and we can take advantage of the updrafts, the propeller will fold, more aerodynamic.
The Tempest is manually launched and landed. However, the plane operates primarily by autopilot.
One, launch. Plane's in the air.
No, it cut the corner really short. It's going to overfly this turn a bit. It's going to come over straight overhead here.
It is controlled from this ground station, a specially equipped van loaded with GPS and radio communications instruments that allow the operator to track the plane and another vehicle called the ground tracker.
That vehicle has a radio node on it that the aircraft actually will orbit. And so what that does is it enables us to make sure that we keep the aircraft close to where our observers are.
The Tempest project is part of a large and ambitious effort to understand tornadoes. The project is called VORTEX2. It stands for the Verification of the Origins of Rotation in Tornadoes Experiment. This spring, from mid-May to mid-June, some 100 scientists and over 40 science and support vehicles will be chasing storms across the high plains of North Texas, southwest Nebraska, eastern Colorado, and western Kansas.
The ultimate goal is to fly through what's called the rear flank downdraft of a supercell thunderstorm. This area is typically free of precipitation, so weather radar really doesn't return much information like it does for other parts of the storm. So the meteorologists are very interested to get in situ data from that part of the storm.
During this time, Brian and his crew will deploy Tempest in an effort to chase down valuable data that may one day help us better understand how and why tornadoes form.